Ladies and gentlemen, boys and girls, Fraser Nation once again for our geometry series. 5.2, we're going to focus on today using perpendicular bisectors. We're coming way back from chapter 2 when we covered bisectors and we covered perpendicular especially. So the first thing we need to focus on is our objectives. What will you be able to do? Students will be able to use perpendicular bisectors to solve problems. First and foremost, you need to remember from chapter 2 that perpendicular means meeting at a right angle. Okay, so anything that meets something else at a 90-degree angle is going to be perpendicular. Bisector means making two congruent figures. Remember, bi means two. So bi means two and sector means cut. So that means that we're going to cut something into two congruent figures. And let's remember that the symbol for perpendicular is an upside down T. So anytime you see that, instead of writing this big word perpendicular, I'm just going to use this symbol. Corresponding dashes that mark line segments means that they're congruent. So in this triangle, I have two dashes, okay? And if you know the measurement of one, that means you know the measurement of the other. So if this is 10, this over here has to be 10 as well. They have to be the same distance. Concurrency is just something you need to know is happening at the same time. And the midpoint of the segment makes two congruent segments. So I have AB. If I have AB and I know that AB is 20 and I know that M is my midpoint, then that means that AM has to be 10 and MB has to be 10. Next. Vocabulary. First and foremost, you need to know what a perpendicular bisector is. Perpendicular bisector is any geometric figure, so your ray, line, point, plane, anything that is perpendicular to the midpoint of a segment. Okay, so first and foremost, you need to know that it's going to be 90 degrees, and you need to know that it's going to be in the middle of a segment. So midpoint, segment. Okay. Equidistance. A point is equidistant from two geometric figures if it's the same distance from both of them. Okay, so if I have a point, let's call this point K, and I know that there's a square over here and there's a square over here, and this is 10 miles and this is 10 miles, then I know that point K is equidistant between that square and that square. Okay? And point of concurrency and concurrency are the same topic. Point of concurrency is where three or more lines, rays, or segments intersect at the same point. So anytime you have something intersecting at the same point, you're going to know where your point of concurrency is. Next page. So we have a couple of more theorems that we want to get into. So theorem 5.2 is your perpendicular bisector theorem. Anytime you have a point on a perpendicular bisector, so in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So if BP is the perpendicular bisector, how do I know that? Well, I'm telling you now that it is meeting at a 90-degree angle. And P is the midpoint, okay? P is the midpoint, so say P is midpoint. So anytime you have a midpoint and you have a perpendicular bisector meeting at that midpoint, then you know that the distance from B to A and B to C are the same. So if BP is the perpendicular bisector, which it is, then AB is going to be congruent to BC. The converse, or the backwards, of your perpendicular bisector theorem says that if the point is equidistant from the endpoint, so in our picture right here, if C is the same distance from B as it is to A, and you know that because of these dashes right here, this has two dashes and this has two dashes, then point C has to be on the perpendicular bisector, which is right here. Okay, and how do I know it's a perpendicular bisector? Well, meets at a right angle, And we know that P is midpoint. How do we know that? Well, look at your two segments. If this segment and this segment are the same, P has to be the midpoint. And finally, theorem for 5.4 is concurrency of perpendicular bisectors of a triangle. Remember, concurrency means happening at the same time. They're going to meet at the same place. And the theorem basically says if the three perpendicular bisectors of a triangle meet at a point, that point is equidistant from the corners. That's what vertices are. The corners of that triangle. Okay? So if perpendicular bisectors meet, so X, Y, and Z are midpoints. So X, Y, and Z are midpoints. Since these are midpoints and they are meeting at perpendicular angles, they're going to meet at point K. I'm telling you that point K is going to be the same distance from each one of the corners, A, B, and C. Okay, so if perpendicular bisectors meet at a point, that point is going to be the same distance from A, B, and C. Next slide. Let's get some examples going. So first and foremost, I'm telling you that line JK, okay, is the perpendicular bisector of segment NL. Okay, and let's go with NK, and let's say JK. Okay, so let's do some examples real quick, shall we? What segment lengths are equal in this diagram? Well, first and foremost, you know that MN and ML are the same because they're both 8. So we're going to say segment MN is congruent to ML. Let's look. Let's see right here. We know that the perpendicular bisector is JK. One of the definitions of the perpendicular bisector is it has to be at the midpoint J. Since we know J is a midpoint, we know that these two segments have to be congruent. So we know NJ has to be equal to JL. And finally, being that J is the perpendicular bisector, we know that K, point K, is going to be the same distance to N as it is to L. So NK is going to be congruent to LK. Okay? So we know these three segment lengths are going to be congruent. So let's put a little dash right there too. Okay, NK. So here's NK right here, and we have an X right here. So that means we're going to have to solve for X. Well, because of number one, we know that NK and LK are going to be the same distance, so they're equal to each other. So I have here 6X minus 5 equals 4X plus 1. So being that we have minus 4 and minus 4, those cross out. You have 2X minus 5 equals 1. So you have plus 5 and plus 5. Those cross. 2X equals 6. So X equals 3. Well, I have X equals 3, but I want to know what NK is. So this 3 is going to have to go right here. So I have 6 times 3 minus 5. So we know that NK has to be 13. And finally, number 3, explain why point M would be on JK. Well, first and foremost, we know JK is the perpendicular bisector. So according to theorem 5.3 says if M is the same distance to the two midpoints, which it is, M is 8 units to N and M is 8 units to L, since MN is equal to ML, since that's equal to 8 and that's equal to 8, we know that M lies on the perpendicular bisector. Okay? And that's because of theorem 5.3. Next. The perpendicular bisectors of triangle ABC meet at point G. Okay, so we know that this is a perpendicular bisector. We know that this is a perpendicular bisector, and we know this is a perpendicular bisector. So we know that G has to be the same distance to each corner of your triangle. Okay, so being that these are perpendicular bisectors, we know that D, E, and F are midpoints. So if I find GC, GC is the same distance to C as it is to A and B. And we know from G to A is 9, so G to C has to be 9 as well. Being that this is 9 and this is 9, and we know that this has to be the same distance, BG has to be 9. And being that we know DB is 6, we know that DA is going to have to be 6 as well. Okay? Well, don't forget your young Quizlet. We have retakes to do. Make sure that you stay in school, kids.